assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
So we know that for part A, the rotational inertia of a uniform rod with a pivot point at its end would be I. This would be equal to ml squared divided by 12 plus ml squared. This would be equal to 1/3 ml squared. Now, because we can then use equation 1529, and this is going to lead to the period t equaling 2 pi multiplied by the square root of the moment of inertia, 1/3 ml squared, and this would be divided by the total mass m times g multiplied by L over 2, essentially the height of the center of mass. We can then find L. L would be equal to 3g times t squared divided by 8 pi squared. And we can solve. So L would be equal to 3 times 9.8 meters per second squared multiplied by 1.5 seconds quantity squared. This would be divided by, again, 8 pi squared. This is equaling 0.84 meters. This would be our answer for part A. For part B, we know that from energy conservation, we can say the energy at the bottom would be equal to the total energy at the top, and this would become the maximum kinetic energy equals the maximum potential energy. So we know that here, this would be equal to mgl multiplied by 1 minus cosine of theta, where here L is the distance from the axis of rotation to the center of mass. We're going to use the small angle approximation where cosine of theta, if theta is a small angle, will be approximately equal to 1 minus 1/2 theta squared. And then we're going to use, if we're going to use a small angle approximation, theta must be in radians. And so we can say here, for part B, the maximum potential energy would be 0.5 kilograms multiplied by 9.8 meters per second squared multiplied by L over 2 multiplied by 1/2 times the maximum angular displacement squared, where we know that the maximum angular displacement is equaling 0.17 radians. Again, L is going to be our answer from part A, 0.84 meters. Therefore, the maximum kinetic energy at the bottom of the swing will equal the maximum potential energy at the top of the swing, and this is going to be equal to 0.031 joules. This would be our final answer. And just to note, we did want to calculate 1 minus cosine of theta directly. Our answer would only be 0.3% off, so extremely small difference. We can safely use the small angle approximation. Again, our final answer for part B, 0.031 joules. That is the end of the solution. Thank you for watching.